Hello! In this video we're going to take a look at hypothesis testing, and specifically we're going to look at the t-test. So if you look here, we're going to start by considering a scenario. Imagine your school has implemented a new math curriculum. After 1 year, you want to see if there's been an improvement in student test scores. Last year, the average score of the students was 346. So here's the setup, and then we've got some scenarios to consider. Imagine that this year you randomly selected 20 students, had them complete the STAR math test. Their average score was 340 with a standard deviation of 60. Do you think the curriculum has made an improvement? Alright, so let's just pull some information out here. What we're interested in is student test scores. Now, we don't actually know the population average of the student test scores, but that's what we're interested in. We want to know, has that gone up or not? Has it stayed about the same? Last year it was 346. So to decide, we've taken a sample of 20 students. So we know my sample size is 20. They completed the test. Their average was 340. So we know X bar is 340 and their standard deviation is 60. Okay, so what we're really doing is we're comparing this 340. We don't know the population standard deviation, but we're saying based on this, compared to 346, has this gone up? And it's looking like not likely, right? The sample average was low, so it's not likely that mu is greater than 346. Now, it's possible it could have gone up a little bit, and just due to random chance, our sample had low scores, and so our sample is. So this doesn't tell us that mu is not greater than, but it tells us it's not likely. So let's consider scenario 2. Scenario 2, similar setup. We still have a sample size of 20. Our sample average is a little bit higher now. It's actually above the 346. So does this mean that the population average, the population mean of all students is greater than 346? Well, maybe, right? We're at 352 in the sample, so I'd say here the answer is maybe. It's higher than 346, but just due to random chance, we could have gotten a sample of high scores. And so it's possible that mu is greater than 346. But we can't be certain. It could just be that we got some scores that were really good in our sample, and it's just due to chance. Take a look at scenario 3. Sample size is still 20. This time, though, the sample average is 380. So now the question is mu greater than 346? It seems likely, right? Last year was 346. Our sample is 380. We could have just gotten some really good scores, and so our population average could still be about the same as last year. But with that high of a difference, with 380 compared to 346, it's likely that mu is in fact greater than 346. And so what we're going to do is we're going to do a test called set up a hypothesis test, and we're going to test this to see, is this difference likely just due to chance, or is something else going on and it's statistically significant, this difference that we're